Let's do all of page 3. Are you ready? I'm ready. Let's do this. Line P is parallel to line Q, and they're both intersected by the transversal T. Well, I want to solve for x, and I'm given these angles. Now look at them. Do they look equal to each other? I really hope you said no. Because that is acute and that is obtuse, and they're totally not equal to each other. But they are same side interior, and these are parallel, which means these are supplementary. And supplementary means that they add to 180. So just do a little math. We have what? 7x plus 5 equals 180. So 7x equals 175, and x is equal to 175 divided by 7, which is 25. And what did they ask for? Ooh, look, they asked for x. Isn't that just lovely? 16. Right triangle's hypotenuse is 6. If one leg is 2, what is the length of the other leg? Well, that looks a little Pythagorean theorem-ish to me. So I have 6 squared equals 2 squared plus x squared. So I have, what, 36 minus 4. Squared equals 32, square root. None of those answers are there, but this is not the square root of 32, and that is not the square root of 32. It's got to be one of those two. So probably means I need to simplify, which means 2 probably goes into 32 16 times. Yeah. And the root 16 is 4, and root 2 is root 2, and so D is what we would get as an answer. Alright, 17. Which of the following sets of angles measures would form a triangle? So what are we really trying to do here? We're checking all that apply, so we're just trying to figure out what they all add up to. So I'm just going to do a little math. 30 plus 40 plus 110, check. 180. 100 plus 70 plus 20, check. Just kidding, not check. Not check, because this is 190. Bad. 90, 45, 45, that one works for 180, and then these guys also work. So just B, that's the only one that doesn't work. Alright, 18. Find the measure of the largest angle. So not x, even though you're going to get x, and it's probably going to be down here. Don't be fooled. We need to just do something with all of that, and this mess here adds up to what, ladies and gentlemen? What? Yep, 180, because triangles sum theorem. So I just need to do a little math, right? We've got our 5, 10, 2, so that's 17x. And we have our 33 minus 23 is 10. So we get that when we subtract 10 on both sides, and we get that when we divide by 17, and that is not the answer. We want to find the largest angle, so this is only 50, so that's probably out. This is, what, 20 plus 33, so that's 53, so that's better. This is 100 minus 23, whoops. And that's 77, so that one would be our answer. Alright, we're continuing on with this page. We'll do number 19, so let's check and see what we have. This little dude here equals this little dude here, and this little dude is 80. We're trying to find angle P. Well, if these are equal in the same triangle, then these are equal here, our isosceles triangle theorem. And then all of these three triangles equal 80 would allow us to do that. If I took 180 minus 160, because of the 280s there, which would be 20. Alright, so what do we have here? Find the value of x if the perimeter of the rectangle below is equal to... Ooh, so many people got this wrong on the test. It was so sad. Perimeter is everything, so we need to make sure we're adding all of them to equal 76, not just what you're given. Don't be all crazy. So we have 2, 4, 5, 6 x's plus 16. So we need to take our 76 minus our 16, which gives us our 60. And x is equal to 10, and that is what I'm asked, so I can circle it with confidence. Alright, so what do we have here? So, which triangle similarity theorem could be used to prove that the following triangles are similar? Well, I need another angle, because right here I have my 90 and my 90, but that's kind of it. So I need to solve for this one. So 90 minus 68 is 22. So then I can use little angle of fun there. I definitely can't use anything that has a bunch of S's because I only have one. So those are definitely all out. And this one's out because this doesn't even work for nothing. All right, 22. Which of the following transformations produces similar figures? Well, dilations do. Reflections are congruent, so technically those are also similar because they have the same shape and they have the same ratio. Vertical stretch and horizontal stretch is just stretching in one direction or the other direction, so it would be like really long or really narrow, and so those would definitely be out. All right, 23. Equilateral triangle, done. All of sides 20. We are looking for the height, so this little dude down here is 10. And hopefully you are remembering now, root 3 is the little situation that goes between the two legs there. So this is our answer.